All right. So many years ago, I bought this dynamic microphone. I got it from Radio Shack, but it's actually a Shure eyeball dynamic microphone. And I'm not even sure why I bought it. It's been laying around in my cabinet for years, many years. And now that I'm doing YouTube videos, I thought by myself, well, maybe I can use it for certain instances. It is a omnidirectional mic. It might even be useful for something, I thought, at some stage. In any case, plugged it into the PC, and then I found that there was hardly any volume there whatsoever. So a little bit of research showed me that this kind of microphone has a high output impedance, and a PC has a low input impedance, so the two are completely mismatched and could not have enough power in order to create a decent volume. In fact, I hooked it up to the oscilloscope and I found that there was only about, I don't know, 4 or 5 millivolts there of output. So then I decided, well, let's have a look if I can build a little preamp for it. And I thought to myself, well, I can just use a handful of components, a field effect transistor maybe, and a few other things. But I thought, well, you know what? Let me see if somebody's already done the hard work and I can just find a circuit somewhere. So I Googled it. And then I found out that there is a little kit that is sold both at Gemaco and also at another company, which I will show you guys, which is coming from was designed in Europe by the looks of it, Velleman. And when I had a look at it, it has a circuit which uses an LM358 op amp, and it occurred to me that that might be a good solution. So anyway, let's have a look at it and I'll show you what I mean. So this is it here, the little kit that I found. Velleman K1803 Universal Mono Preamplifier Kit. This company here, EIO.com, they seem to sell it cheaper. Seems to be produced in Europe, Belgium or something. Yamaco also has it, but they want more money for it. But they did have a handy specification section. I actually downloaded a PDF with the circuit on it. Specifications here. These specifications seem to be a little bit inaccurate. It says output impedance 1 k ohm, but as far as I can tell, it's 10 k ohm, more or less. If you load it down with anything less, it seems to have some distortion. In any case, it works. I've already tried it. So, and this was the document that comes with the kit that you can download as a PDF. It's actually aimed at beginners actually, so it's easy to make. So it's got some assembly instructions and how to use the tools and stuff like that. Okay, so this is the circuit. I have only made a few changes to it. One is reflected on the circuit here. I put pads on there for a capacitor that can go across the trim pot for setting the gain. This allows me, if I need to, put some bypass on there to make sure that any high frequency signals are not going to get out, just in case there is some oscillations or some high frequency stuff that it picks up. This would allow me to filter it out if I find that there's a problem there. Also, I am putting on the actual PCB, I'm actually putting bypass capacitors on the 12 volt rail. So I'm using 12 volts because I'm planning to put this inside of my PC. I've got an old PC there, you know, with a big case and plenty of space. Um, I might put a special socket on there for this particular microphone because it has a phono socket plug on the end, and I've got some sockets in my supply there. So and then I'll wire this in line with that socket for that plug, and then if I plug that microphone in, then it will be preamplified. So I have laid it out with KiCad. I'll be using KiCad, and KiCad, this is version 6, which has been recently updated. There are lots of videos on YouTube on how to use KiCad, so I am not going to go into that here, other than showing you, what I have designed and so on. If you are really interested, let me know in the comments, and I will do a video on KiCad if need be as well. Any case, so we're going to first go to this schematic editor, and as you can see, the schematic here is very similar to what you saw that came with the kit. As I said, I made some changes here. I wanted some bypass capacitors on the voltage rail, because I have already built it on a breadboard, and I've noticed some interference in here and there, but you can't really tell. The breadboard version, I'll show it to you in a minute. Of course, has lots of little leads and lots of opportunities for stray capacitances and stray inductance and so on, which wouldn't exist on the little PCB. So when you're using KiCad, you have to make sure that when you put the components in, that you have the correct footprint. And I'm going to be using surface mount components for most of those, as I'll show in a minute. And as you can see, like this capacitor, also while we're at it there, you notice I've only got a single capacitor there, not two of them like was on the other circuit, because I'm using surface mount capacitors. They are not polarized, so I don't need two capacitors there. One will do the job. And I have selected for each one of those, as you can see, it's SMD capacitor 1206 is the size. They're a little bit larger, so they're easier to hand solder. And it says hand solder over here. That means that the pads are just a tad larger, so that you can put the fine soldering iron tip actually next to the component, touching the component and the pad, so you can actually melt the solder onto them. Makes it a lot easier. If you don't have the hand solder ones, you might end up with the ones that the little pads on the PCB are right underneath the area of the component that has to be soldered, and that is really set up for manufacturing, where they're using like an oven to heat the thing up, and the components will melt down onto the PCB with solder paste. And if you use that kind of pad, you can do it by hand as well, but then you'd have to put some solder paste on there, line up the little components on the board, and then use like hot air or something like that. And we're not going to do that. We're going to hand solder it. So I've selected the right pads there. So and same goes for all of those. The trim pot too, I selected the correct, as you can see here, the correct layout. If I'm not going to use a trim pot, I can actually just solder little wires on there and use a standard potentiometer, mount it somewhere else if I wanted to. So that's kind of flexible, and that through hole plated. Okay, so there's not much else to say about the schematic. I'm using sockets, 4 and 2-pin output sockets, and I have laid it out on the a PCB here. So what I do with the PCBs is I'm going to be using photoresist, and it's a negative photoresist. So the black areas here are the bits that are going to be removed from the PCB, etched out, and I want to limit the amount of etching that is to be done. So what I tend to do is I fill the whole PCB after I connect all the components up and put traces down for them. I will then place a fill the PCB up with the ground plane, and then it will automatically then connect the components, as you can see on these places like ground here and so on. So I don't have to etch as much off, and it makes it a little bit easier because I don't have to connect all the grounds. I have one little piece of wire here to demonstrate how to do that, which is actually on the other side of the PCB. I'm working with the front FTU front copper for all the traces, and that is where the surface mount components are going to be. On the back, where the blue trace is, actually is where the non-surface mount components are going to be, and so they won't be on the same side. We'll get into that in a minute. Okay, so that's the PCB. Now what you do is after you've laid that out and there's no errors, you will plot it, and I use like clear film in order to make like a negative that will go onto the PCB on top of the photoresist after it has dried, and then put the ultraviolet light on it, and for a minute or less, that's all it takes. So I plotted. I do two plots actually, a mirrored plot and a non-mirrored plot, and I'll show you in a minute why. And you just say plot, and then it takes less than a second, and it will create a PDF file. And so I will print this out, and then I double check that all the components just on a piece of paper, to make sure that all the components actually fit. Select the right footprints, and we can actually do that now and switch to that. Line it up with the camera here. This is what I've printed out then, and so we can take the actual components and line it up with the traces. So this one is going to fit. This is the LM358. This is a SOT 26, whatever it's called, I don't know, package. And we have, this is the trim pot. Goes over here, and as you can see, the little legs, they fit. Mind you, this is going to be actually be on the other side. This is going to be the top side, right? And they will be mounted on the other side, but nevertheless, you can line them up and see that they're going to fit. There we go. And we have 100 microfarad capacitor. Again, legs line up, which would fit here. There's going to be another little bypass capacitor. I decided to use this thing here instead of a surface mount one. I have these laying around. Going to be fitting in there into those right next to it into those holes there. And we have capacitors, like 1206 capacitors. They're going to fit on these little pads, and you see how the pads are a little bit wider than the components, and that's the hand solder bit, so you can actually put a little bit of solder on each side, which is good. And resistors, this is going to be the actual, this resistor is not the right value, but it's just a demo. I've got the resistors in a strip, you like it like that, but that is the right size, so they're going to be, you know, like that. So everything looks good so far. Then we have the sockets. I'm going to use a 4-pin socket here for the power and the input. See how the little legs line up? Again, they'll be on the other side of the PCB, of course, but they fit there. And the output's going to be a 2-pin socket, 2 little legs, lines up nicely, and they too going to be ending up over here on the other side of the PCB. So that's basically it. That's why I printed out as a double check, because it's a pain in the neck, you know, after you make the PCB and then you find out the holes are in the wrong place and you got to mutilate things in order to make it fit. Okay, so this is the one that would actually, how we're going to be printing it out on the vellum or on clear um, overhead projector film. And the idea is that the printed side here is actually going to be down on top of the photoresist. So there is no light's going to be bleed through the film, you know, and make it less sharp. And so that is what we can be doing next. We can prepare the PCB. Oh, and actually while we're at it, this is the breadboard version that I made up for testing. And as I said, there's leads and wires everywhere, so I did notice a little bit of sort of very high frequency stuff coming out of it, but I think that might be because of some stray capacitance or resistance somewhere and interfering with the signal. So should not be happening on the actual PCB. And so I tested this thing, and it seems to be working well with OBS Studio and some other software that I have to make recordings. So I believe that is a good way to go. Okay, PCB next.